Okay,
All right. So,
you're on.
hey, stargazers. I think we're on here. Welcome to our little world, centered on the outer world that we call the SBAU Astro Hour. It's all for the longtime Astrophysics and Telescope Club, known as the Santa Barbara Astronomical Unit. My name's Ronnie Herron, your weekly host for this, our 268th program for the week of April 13th through the 19th, 2026. Meaning that I'll get you into this little crazy and expanding topic centered on the cosmos around us, but and then I'll probably get lost in the discussion myself, and you'll be on your own as well. But listen, you're going to learn a lot. You can make comments and ask questions. I'll introduce you to our club's brain trust around me on the screen in just a minute. If you like what you see, please come join us at our SBAU First Friday meetings out at the Museum of Natural History. 3 weeks away, May 1st, we'll be at Fleischman Auditorium. A week later, the second Saturday Star Party, and SBAU.org is us online. Big topics for discussion this week. Talk about NASA's Artemis 2. It's back home. What a cakewalk around our nearby satellite. I like our president's talking points. He described it as a drive-by shooting of the moon. And I'm wondering if anybody's going to be able to ID which continent is exposed on the lower left side of that Earth shot in color. And the picture will show you a lot of photographs this week. And listen, starting up tomorrow, the Lyrids meteor shower. There's a apparent object involved, a comet. And so what if black holes ain't black? What color aren't they? Or are they? We're going to talk about that. Wait till you see the diagrams and the scroll down graphics on this topic. It's like
I'm going to say purple.
silly science cartoons. What'd you say, Tim?
I'm going to say they're purple.
Purple holes. Let's meet the gang, shall we, ladies and gentlemen? The captain of our Astro Hour Starship, who becomes our professor of physics at Broder Hall. It's President Jerry Wilson and his entourage. Jerry.
Good morning, everybody. Good morning, Joyce, and my grandkids, Calvin and Riley.
They're out there in the audience cheering you on. Co-pilot and first mate, Captain Outreach, the coordinator for the club, the coordination of goodies. It's Chuck McPartland, who, like Jerry, is married to a Pat. His wife, Pat McPartland, is also our incredible merchandise manager and treasurer. Former beloved science professor at Westmont College, chief birder and bread maker, Tom Whittemore.
That must be me.
That's you. I love your shot with nature in the background every time. I don't know
Grapefruit tree.
That's a great man cave you're in. And listen, here's our resident lens crafter, telescope expert, and specialist on matter as plasma, Tim Crawford. Tim.
Plasma is me.
One of our speakers in December. I'm looking forward to that. Okay, gentlemen, we got the silly stuff. We always start our shows, and we're into our 6th year here, 2026, having started in March of 21. So we always like to have a little levity here, a little Far Side cartoons. And what is this? The moon talking, Jerry? You want to?
Yeah, this is the moon musing. This is kind of on the in the vein of the planet Doug. But anyway, here comes the humans again with their mature little research, so evolved. And it goes around and it comes around, and they're looking at the backside of the moon, and it's all giggles and childish jokes.
The bottom line is the moon is ticklish, and the Orion looks like a pencil.
Yeah, it's a space capsule.
That's the Orion.
It's from the same artist.
Okay.
Okay, don't move. The moon is drawing planet Earth.
Okay.
Don't like it? And he says, no, I love it. I just didn't know I looked like this to you. And it's a picture of a crescent. And he says, sometimes.
Oh, yeah. Yeah.
They were stunning pictures, as you noticed. Are we still out there? Is it still the moon? No. Chuck, why don't you guide us through this one? Read us the caption.
I like this one.
Okay, you've got some astronauts, and it looks like a combination of their capsule or they're repairing the Hubble. But anyway, they're fiddling around with a spacecraft, and one of them pops out and says, "Mike, never mind fixing the feed to Houston. Get the cable going. The NCAA final starts in 5 minutes."
March Madness in space.
Yeah, I
Yeah.
noticed
Yeah.
that they put running boards on the
Yeah,
spacecraft.
yeah. And they've got an anemometer on the little antenna there.
Oh, yeah.
When did runner boards go out? About the 30s?
Yeah.
Okay, Mr. Whittemore, Dr. Whittemore, would you like to tell us what this is all about?
Yeah, it just says, well, there goes the neighborhood. And it looks like one of us, or something flying
Couple of
by.
moon mannequins or
The
whatever.
Artemis capsule.
Moon Muppets. Everything will be Artemis too, and jokes, won't it? How about you, Tim? You think you could get us through this?
Oh yeah, I really like this one. There's the 1969 Apollo 11. That's one giant leap, and then which was a fabulous quote. And then in 2026, toilets broke again.
Toilets. Okay.
We've really moved up.
Okay.
I
now,
didn't get this.
This is
yeah,
kind
well,
of a
that's why
tongue twister.
the president's going to explain it.
Okay, this is 1/5, 2/5, red fifth, blue fifth.
Yeah. Fish with a lisp.
It's a pun on a childish rhyme. Only instead of fifth, F-I-F-T-H, put in the word fish, F-I-S-H.
Oh, one fish, two fish. Oh,
Red fish, blue fish.
I never heard that.
Yeah, that one went by me.
if
Did you ever hear the childish taunt? Let's see, now I can't remember it.
Sounds like a Dr. Seuss thing.
Lambs eat oats, lambs eat
yeah.
oats, and
Little
Mares
lambs
eat
eat
oats.
ivy.
Little lambs eat ivy.
lambs eat oats, and mares eat oats, and lambs eat oats, and little lambs eat ivy.
Dozy
Eat
oats.
ivy too, wouldn't you?
Yeah.
Yeah.
Okay.
or what is that song that Hal sang as he was being decommissioned?
Oh, row, row, row your boat.
No, that wasn't it.
Daisy.
Daisy.
Daisy, yeah.
Okay.
Okay. Thought we had more than that. Is that six
We
or
had,
seven?
I had two of them in there, as a copy, but I cleaned that up.
Well, my daughter sent me a cute one about a week ago that I forwarded to you. I guess you lost it or didn't get it. It may still be there. It's a Calvin and Hobbes without the tiger, but
I thought we included that one.
I don't think so.
Okay, well, I'll go back and look for it.
Turns out he's just a speck and he's trying to compare himself to the universe. Okay, Artemis 2 is the main subject today, isn't it? Obviously. There it is.
So this is the whole Artemis idea. The Artemis program is a series of NASA missions designed to return humans to the moon. Following the successful uncrewed Artemis 1 in 2022, the crewed Artemis 2 mission just returned after a 10-day flyby, including a splashdown on April 10. Future missions include Artemis 3 in mid next year and 4 in the following year, aiming at manned lunar landings. Artemis 1 and 2 are completed. Artemis 3 is planned for next year. It is the first crewed landing of the Artemis program, aiming for the lunar South Pole.
Jerry, I heard in this Artemis 2, they were complaining that they didn't quite have the capsule ready for landing upright, and they were having a little bit of difficulty with that. So 2027 may be a little bit early.
Little, might be.
And they've totally canned the Gateway, was the last I heard.
Yeah. Down here you see an Artemis 4, a continued lunar and assembly of the Gateway station. That will no longer take place.
Really?
Unless we change presidents and they put it back in.
Yeah.
The
current plan is a little bit cuckoo.
Yeah. And this one reflects crewed landing of the Artemis program. They have assigned and then reassigned the Artemis lander, and I don't know who has it now. It briefly passed through the hands of SpaceX. And
I think it's a competition between SpaceX, and Blue Origin.
Yeah,
And for Artemis 3, I think they're going to just go out in orbit and practice docking with the two versions. It was one of the things I saw.
right.
I think I heard that too, Chuck.
Yeah.
Do you suppose
Anyway, we'll see what happens here.
Yeah.
They're very optimistic. This is, if you don't get it, there's a lot of tension in this space race. The US desperately wants to beat China to the moon. China's coming on very strong with a similar program that includes a gateway. And we are, at the same time that we want to speed things up and get it done, we're defunding NASA. Propose cutting it by 32% next year. So it's,
even though there's 5 dots on the screen there's only 4 of the flights, aren't there?
What good is science when you can have chaos right here?
Yeah.
Did they fire Artemis 1 fully pressurized, like there were people on board, or they just
no,
leave the air?
no, there were no people on board Artemis 1.
But I think it was they had the life support system going.
Yes.
Well, that means they would be full of air to make sure that it doesn't leak. And
Yeah.
okay, got it.
It's probably not straight air. It's probably a helium and oxygen composition.
This
Okay.
you have here, Jerry, is going to be
spacecraft is that it only is 5 pounds per square inch of atmosphere, and it's almost pure oxygen. The atmospheric pressure here on Earth is 15 pounds per square inch and 20% oxygen.
Huh.
So anyway,
I think, wasn't it oxygen that killed the 3 astronauts on the stand in one of the early Apollos?
Yes.
Apollo 1.
that was
Yes.
the fire that killed them.
Yeah.
Well, that's true, but
The,
because it was all oxygen.
One of the, I forget what the Russian space program was, but their astronauts died on reentry because the seal around the hatch sprung open and the capsule evacuated and they
Lord.
died of asphyxiation.
Well, this picture, Jerry, shows them going way out above the moon. They didn't come in low like they did orbiting during Apollo.
Let me give you 3 key words for this: not to scale.
Yeah.
Well, I understand that, but did they just cruise along the same height, couple thousand feet as Apollo?
No,
9?
they went way past the moon.
Yeah,
That's what I'm thinking. That's what I'm wondering.
they designed this orbit around the moon not to benefit the passing of the moon, but to ensure that if they do nothing, they would come back to a re-entry point that was automatic.
Oh.
So this is all one big shot with all the gravity effect doing all the steering.
But if they were getting shots of the far side of the moon that we never see,
Yeah,
it'd have to be lit, wouldn't it? Or wasn't it full moon toward
it
us?
depends. It depends how long you expose the picture for, and you'll see that in pictures of the Earth which are coming up.
So they got some pictures of just craters mostly.
Yeah, and it wasn't full moon.
Yeah. Now this is a picture of the Earth as they're going away. The sun is on the other side of the Earth, so this is the nighttime on the Earth. And you can see city lights around here. And you can see the atmosphere lit up here. This is from the sun being on the other side. So this part of the atmosphere is backlit. Then down here, that is either Australia or North Africa, I believe, with that much.
Wondering
Look though, there's a little island on the far left bottom. So that could be the Red
Could be
Sea
Tasmania,
on the
couldn't it?
edge there.
Oh, here that could be Gibraltar.
No, I'm thinking that could be the Red Sea.
Yeah,
And this is Saudi Arabia mainly that you're seeing.
could
So
be.
that's a Strait of Hormuz then, Chuck.
Strait of Hormuz would be up in the darker area, up
Yeah.
a little ways. Yeah, up in
I
there.
think this is Gibraltar. And this is North Africa. This is Sahara Desert. But I don't know.
Yeah, could be.
Okay. Now, this same picture was taken with a longer exposure. And that's this picture.
Wow.
this is the same picture, but it's exposed longer. And here you can see what was at first represented as the sun's corona, but the sun is way small. We're really close to the Earth. This is actually the zodiacal lights down here.
I wonder if that's Venus, huh?
Yes, this is Venus.
Yeah, yeah.
Wow.
What is the outline, the very faint outline all the way along the left edge of that image?
I don't know. There's this one. I think that my guess is that's the Sahara Desert, and this is Gibraltar.
Okay.
We see the Earth as blue because it reflects the sky above it.
No, because the
ocean.
water's blue.
Yeah.
But water is not blue.
Yeah, it is.
It's reflecting the sky, isn't it, above it?
No, no,
It's not. It's blue.
no.
Mhm. Or greenish blue, depending on depths.
How much
and-
algae there is, yeah.
yeah.
That's
Thought
a
water
pretty
was
cool picture.
colorless.
What's that?
I thought water was colorless. Water
Well,
is
it is in
a
small
compound.
quantities.
This isn't just pure water either.
You know, you go down about 200 feet deep in the ocean.
Very dark, very
it's
dark.
pitch black.
Right. It's called
At all.
Beer's Law.
Yeah.
Well, I always heard that the color blue was due to something having to do with the influx of the sunlight and ultraviolet being.
That's the blue sky.
Yeah, that's Rayleigh scattering.
Right.
The scattering cross-section is proportional to the inverse fourth power of the wavelength.
Right.
So it's very heavily in favor of scattering blue over red.
And I asked an oceanographer once what they attribute to the green in the seawater. And he said, "Oh, great question. It's chlorophyll."
Yeah.
Yeah.
Oh, sure.
That's where most of the Earth's oxygen comes from, is the top 3 feet of the ocean.
Oh, wow. Didn't know
What's
that.
living in the top 3 feet of the ocean?
Yeah, that's right. Top 3. Well,
Yeah.
A question I've always wondered, I'll throw in real quick. All those shuttle launches and all those orbits of the Earth, you'd think they'd get a shot of the reflection in the ocean below them of a full moon behind them.
yeah, you get a glint off the oceans. If
I've
the
never
sun
seen
were
it.
up, you'd get the glint of the sun. And if the moon were up and full, you'd get a glint of the moon.
But I've never seen a picture.
See this? See that whitish haze there?
Yeah.
That's Earth. It's the opposite of earthshine. It's moonshine.
Moonshine, yeah. Yeah.
But my thinking was it might be concentrated like seeing a Christmas ornament, which is round and smooth,
Yeah.
and all the lights concentrated into one little part that's very bright.
Yeah,
You would think that would happen down on the surface of the ocean below it.
it's trying.
It's dry.
Okay, now for this trip to the moon, NASA made up flashcards or cue cards for the astronauts to reference as they went around, showing the backside of the moon and the transition to the backside.
It's really washed out.
It's very
I
washed
don't know
out.
if you want to risk going to the other version, but
No, I'm game.
all right.
Wow. Artemis is on the way. How many Apollos were there? There were about 7 or 8 of those. Weren't there missions?
17.
Yeah.
17?
That's a lot better.
Okay. So this is Moscoviense Basin. Moscovian. Anyway, I can't pronounce Russian. The Mendeleev Basin. Got that one okay. Korolev Basin. The reason these are in Russian is because Russia was the first person or first country to take pictures of the backside of the moon. This is Jackson Crater.
It's near Jackson Hole.
Yeah, Jackson Hole. Yeah. Apollo Basin, South Pole Aitken Basin. You'll see that prominently coming up. And that is of interest because that's the reason where everybody is planning to build a metropolis down there.
Huh. Huh.
Do
Do you
Because
see
of the
that
chance
from
that
the-
there's water.
Do you ever see that South Pole from our side?
You can see it right exactly straight, you know, what is it when you look at a mountain range and you see the profile of the mountain?
Silhouette.
Yeah, you see a profile of it.
Yeah.
You can't look down on it. Only spacecraft can look down on it. And the first spacecraft that was launched was a collaborative spacecraft with the Air Force. And that was called Clementine.
Oh yeah.
And they were looking for radar reflection from hydrogen bonds as in water, and they got positive results. First one to suspect there was frozen water at the South Pole.
Hmm.
I think we need a good Matt Damon science fiction movie. Put him there throwing potatoes.
Now,
But he'd have to be rescued.
Yeah, that's true.
Yeah.
He's always getting rescued in all his
He
movies.
could be skating across one of those frozen lakes in the bottom of a dark crater, you know.
It's probably coming.
This is the Moscovidium one, and this is I forget the other name for this, Mendeleev. And this is a image of the Apollo spacecraft superimposed on an image of the backside of the moon. This is a put together illustration. It's not an actual photograph of this juxtaposition, but this is what it would have looked like if you were outside the Apollo spacecraft. It had a lot more power from the sun, solar panels, than the Apollo did. And then this is going point first, and the heat shield is actually at the interface between these two parts.
Well, for landing, they're going to need a LEM, aren't they? With legs.
On the moon, yes, whatever it is, the spacecraft will not land on the moon, and if it does, it's not taken off again. So this is the proportion of the near side of the moon that was seen by Apollo astronauts, because they were basically orbiting around here. This is area not seen by the Apollo astronauts. And in here is a very famous basin, the
Oriental?
yeah, that's it, Oriental. There's someone on news kept calling it Orientali, but I guess they don't know how to pronounce Latin. So this is it's a massive impact crater with concentric rings, and we see it in profile on the very edge of the front side of the moon. So this is the transition region between the front side and the back side.
Oh wow.
It's a crater or a mare?
Take your pick.
Yeah.
Maury.
The mares are craters.
Yeah.
Got it. Okay. Wow. Well,
Well, it really is a transition there. You can really
how did
see
we get that? How did we get that picture?
Orbiters.
Yeah, orbiters. Yeah, the moon has been completely 100% photographed by spacecraft.
Of course, yeah.
Lunar Reconnaissance Orbiter and the Clementine mission did a very good early job. The Clementine mission was in early 1990, 1991, 1992.
You know, Jerry, I've never seen an image like the one you had there that showed that transition from the front to the back, and with so many craters on the back versus front. But look at that.
Yeah, this is the front side with all its C's. Now this is just lack of detail in here, but this is all what they call lunar highlands, which is just crater impact. This side is where the mass cons are that created the Maria, the big multiple asteroids that slammed in and broke through the crust, and it filled up with lava, which then froze in seas. And the moon is off balance. All the heavy mass is on this side, facing Earth.
And Tim, I think that discontinuity there is just an artifact of how they rendered it. I don't think it's actually such a distinct transition.
Oh, okay.
Yeah,
Okay.
this blur down here is just lack of detail.
Okay. Okay. Very good.
Okay. This is a picture from the backside taken out the window. I think it was taken with a cell phone.
Really?
It's not a very sharp picture, but it's a very dramatic picture. You see the backside and the front side. See our familiar, the Bay of Crises, I think up here.
Bay of Rainbows.
Bay of Rainbows, okay. And down here you see the what is it? We just printed
Oriental, yeah.
Oriental, yeah. On the backs on the Terminator, and then you see backside here. So we got a lot of structure for the moon that we don't normally get. This one I just put in there. This was a handheld cell phone picture out the spacecraft of the Milky Way.
Wow.
I don't recognize any patterns here. There's a lot of dark nebula here. So I assume this is toward the core. Maybe
Yeah,
this is the
it could be the pipe down there, the dark nebula.
yeah.
So you're looking towards Rho Ophiuchi.
That's it. I was trying to think of Rho Ophiuchus. That's what it looks like to me. See these dark streaks going this way and that way. So
Wow.
okay, I got to transition back. This thinks it's the last slide.
That is the last star.
The kitties are all raring to go.
We're about to talk meteor showers here.
No, we got more moon.
Yeah, we got more moon.
Oh, we're still on the moon.
This Artemis mission was really, really fabulous. I had a really good opportunity to hear some of Neil deGrasse Tyson's comments
Yeah.
on why they don't spin the spaceship, and so they could avoid all the lack of gravity. And
In a little spacecraft like that, you don't spin it because you'd have to spin it at very high speed.
yeah,
Appreciable gravity.
the other thing is, he said, why don't they just take the Zodiac boats over to the boat? Why do they wait for a helicopter? Why all the falderall? You know?
Well, yeah, but they've come back from 10 days of not walking and no gravity, or very low gravity. And if they go into the well deck where those Zodiac boats would go, then they have a whole bunch of ladder backs to go up, ladders to go up.
I didn't know that. Okay. Not only that, but man, they'll get beat to death after being in space for so long. You know, that's going to beat you up pretty good.
Yeah. Yeah.
Well, I heard that the Apollos went backwards and had the moon behind them and couldn't see them until the last minute they turn around. I'm wondering if they did the same thing with Artemis.
I don't know. They
Something
did have a lot of
about-
pictures of the Earth.
Yeah.
Being ready for the burn that slows them down, that would have to be.
Yeah, but Artemis didn't do that.
Okay, so they were pointed toward it, maybe.
Well, yeah. They're showing it as pointed away as they approach, it looks like.
Yeah. This is the coming in. There's the capsule separated from its power stage. So this is the going out. And here you're going, there are windows in it. They made, there are windows around the front.
Yeah.
And so they can see where they're going. And there they can see where they're going and out the side.
Yeah.
And then here they're seeing where they're going back to the Earth. And then
They really did put much bigger windows in.
yes. And
You know, that rim that I was telling you about in that image, when you were saying that's the Sahara Desert, the outside of that picture, right there, there's a faint rim, and all of a sudden it occurred to me that that's the window.
Oh,
Yeah.
this thing here.
Yeah. And
Yeah, that's the window.
Yeah, that's the window. So I was wondering, what is that? You know, what's the rim? Get the big
Wonder no
window.
longer. Okay, so we're back up here. This is the famous Earthrise of the crescent Earth. You'll be seeing this a lot in coming years.
But
Well,
this is moon. This was Earth set that they
Yeah,
did.
that's right. It was Earth set. Yeah.
They're going away from the Earth, Eddie.
This is the South Polar region. This is the Aitken Basin. That's the South Pole where everybody's going to build their cosmopolitan centers.
Wow, wow.
And, so the craters here, some of them are in perpetual darkness, and they have frozen ice at the bottom of them, water ice. And then on the rims, you can put the rim up, and the rims are always in sunlight. So you can put solar panels up there, and you get it. But the U.S. is opting for small nuclear reactors at different places around the moon, including the South Pole.
Wow.
This is a face-on picture of the Oriental Basin. You can see this the concentric rings of whatever it might be things hitting that were in a line, but I think it was one big thing that just disrupted a lot of layers. And the weakest layer got thrown back the farthest, and then as it got into deeper material, it threw that back not so far.
You can see the buildings now.
You can what?
No, they're not going to build here.
No, this is on this. This is not the South Pole.
Oh, it isn't. Oh, okay.
But this is, you can see all these little pebble lines out there where crap that was thrown up here just sort of skidded into the surrounding lunar material scape. Very symmetrical pattern.
Looks like a pig snout.
Tim, that's where they were going to build a restaurant, but it wouldn't have any atmosphere.
Mm.
But there's two holes. That means two collisions.
No, I don't think so.
Oh,
I think it had layered materials, and this layer got the brunt of it and peeled back more, and then there was a more rigid layer down here that finally got disrupted, and then there was a lot of lava that stayed hot. It didn't cool down real fast, and then it formed sort of a mini sea with a flat lava lake, like this guy over here. But this, I think, is much older.
Now, once you said that they're going to use lava tubes to put domiciles in.
If they find any, yes.
Okay.
And they found a couple.
Yeah. Yeah, we got a couple of candidates on both the moon and Mars.
Okay.
we have any commentary from Tom Whittemore?
Mm-mm.
Well, he just gave you the bit about the restaurant. Didn't have any atmosphere. They serve upsidasium.
You know how Whittemore likes to dominate the conversations on that.
This is a picture of a lunar eclipse, sort of. It's a solar eclipse, actually, by the moon.
Oh.
But of course, the moon is much closer to the observer than the sun is. So the sun, it's not like an eclipse from the Earth where you see prominences around the rim because the sun and the moon are about the same size. Here, the sun is much smaller, like this, than the moon is. And so all this stuff showing around here is not solar atmosphere. This is illuminated dust in our solar system, also called
Zodiacal light.
yeah,
What is it? Zodiac what?
zodiacal light.
From the zodiac.
This has been represented in news sources as the atmosphere of the sun that you see in eclipses, and that's not the case.
But the Earth's not
The
back
corona,
there.
that's not the corona.
Oh, it's not the corona. Okay.
No,
Where is the Earth in relation to this?
probably about over here, I think.
What is behind it? Okay.
Yeah, it's an eclipse. And
Does
then
anybody-
neutral eclipse.
Does anybody know how they woke them up?
Wokua.
But on Artemis, don't they usually
Oh,
radio tune?
oh,
Or
they
something?
used to play music to wake up people. Yeah.
They did every day.
Okay.
You know what would have been awesome? Just totally awesome, especially if they're about to wake up right here when this picture is taken, is Sprach Zarathustra.
Yeah.
The
Ricard
2001
Strauss.
theme.
I believe this is Venus down here.
Yeah, it looks like Saturn on the lower right.
Wow.
Dude.
Yeah, it does.
So
Wow.
that could be Mars back there then.
Yeah, this
Holy
is,
mackerel. Look
Yeah,
at
that's
that.
Saturn.
oh, this,
Saturn?
yeah, it could be.
You can see the rings without a telescope.
I don't know, possibly Jupiter. What do you think, Chuck?
I don't know. I think this is handheld, so there might be a lot of jitter in whatever they're doing.
There is, but all the other things up here are points. Of course, this is much brighter, so you'd see the errors more.
Well,
We'll research it and see if the caption.
Aren't they doing a project for, is it National Geographic or Scientific American?
Yeah, this is a picture of Venus, and
Venus.
Jupiter. What's
Wow.
that?
I heard that pictures were being taken for a special either with National Geographic, I think.
Yes, I've read that.
Wonder who was in charge. One of those, maybe the woman.
they've all been fired.
You remember when they had to isolate them the minute they got them on the ship and out of the water? They'd be inside a Airstream trailer for about 4 days.
I don't think they had an Airstream trailer on that recovery ship.
Not for this one because they didn't land on the moon, but the Apollo 11 folks did.
That's right. You're right.
And I have a copy. The ship that was bringing them in, the first point of entering the U.S. was going to be Hawaii, and Hawaii, partially as a joke, they have very, very strict customs regulations, and so they had the astronauts fill out a customs form. And I have a copy of it somewhere. And one of the things it asks, is what are you bringing back? And they said, 60 pounds of lunar soil. And then it said, were you exposed to any diseases? And it says something like, remains to be seen.
Remains to be seen. Well, apparently that lunar dust, which they were exposed to, is very, very treacherous.
Yeah.
Dangerous. And the whole suit design for people exiting on future Artemis missions where they're going to walk on the moon, the suit design is very different. It's a person in a spacesuit will never be inside the capsule or any of the facilities. They will what do they call it? Park the suit and clip it to the vehicle, and then they'll back out of the suit, but the suit will never go in the capsule.
Yeah, they actually were worried because that stuff was so abrasive that it was damaging the seals on the door.
Right.
On the Apollo landers.
Oh, is that right?
Yeah.
If they'd have been there another week, they wouldn't have been able to seal the capsule to get back.
And Ron, you probably heard about in the lunar rocks, these little insects that came out. Did you hear about those?
No, what are they called?
Lunatics.
Okay, well, not building on lunatics here. This is the moon on, I guess it's Thursday, April 20. Oh, today's the 23rd.
Today's
No,
the 13th.
13.
This is next Monday or next Tuesday. And this is what the moon will be like, having sunlight. But this is when the Lyrid meteor shower happens. It peaks on that day. We would wait till next week to talk about it, but that's during the thing when it happens. And so it overlaps the transition in week. So we're talking about it now. But it's going to give here's the radiant for the thing at 4 in the morning.
Mm-hmm.
And it's going to, you look up in this region around here, and you'll see the meteor shower. The moon will not interfere tremendously with it. You can see the moon is not in this frame. So anyway, get up real early before the sun. Get your chase lounge out there. Get some warm coffee. Don't fall asleep like I do. Okay.
Lyrids, huh? Lyrids.
The Lyrid meteor shower. Now, this is an article by Claire Lamon from the April 2026 issue of Physics Today, publication of the American Physical Society, which I've been a member of since 1962. Half a century after the discovery of Hawking radiation, we are still dealing with the quantum puzzle it has exposed. So Claire is a cosmologist, science communicator, and postdoctoral researcher at The Ohio State University in Columbus. More of her work can be found at, and you can look at that up. So she put together a really good cartoon discussion of that. And so I copied it, and we're going to go through it. Presenting the black hole as a region where space falls faster than light. Among a number of these claims, they're all physically true, but they'll challenge your imagination. Once you pass the event horizon, this ring, the central singularity becomes your unavoidable
future.
Future, yes. This is famously inescapable. Now, singularity refers to division by zero, and that's not allowed in physics or in math. It's not even, we assume that dividing by zero is infinity, and that's not the case. It simply confounds math. It doesn't work. So we know that that's not a description of whatever happens, and the universe doesn't permit any other singularities. So these are much more complicated structures of time and space mixing. And if you were to think classically of getting down to the singularity, you would approach the Planck length, which is the smallest thing that you can have the uncertainty principles with. It's not the Hubble constant. So anyway, the Planck length and the classical physics, general relativity is simply doesn't apply there. It's an extrapolation. And you have now entered, as you get close to the singularity, you now have entered the region of quantum mechanics.
Can I ask for a clarification, Jerry?
Yeah, go ahead.
The singularity is the single point in the middle.
No.
Is it?
The singularity is a phrase that discusses something outside of our universe that you would think, and if you think classically, it would be a point, but it's not a point. Brian Cox said, if you want to think of the singularity as a point, think of it as a point in time, not a point in space. Because inside a black hole, you're mixing space and time, and by the time you get down near the center of it, you're dealing with an object in time, not space. So you just need to not think of that. It's kind of like that ancient medieval cure for hiccups is you run around the church 3 times and don't think of a fox, and that'll cure your hiccups.
I've never heard that comparison.
Okay.
Worked every time.
But quantum physics tangles, and as you get to the singularity, you're in the region of quantum, and that tangles the classical theory. In 1974, Stephen Hawking applied quantum field theory to the space-time metric in the event horizon. The classic cases, there's a lot of, when you talk about relativity, you're dealing with one frame and another frame. And from very early on, from the 1930s, the 2 different frames are frequently defined as Bob and Alice. So those are 2 different people in 2 different frames. And they're continuing that too. Alice and Bob on the Quantum Express. This is like this, it makes sense. Curvature is uncertain and really gets confounded over here. More curvature, more uncertainty. So you get toward the center of the black hole, it's beyond uncertainty. So describing a field under the quantum framework works fine in a flat space-time, but in a very curved space, around a black hole, you end up with an uncertainty in the local energy density. Now, because space is highly curved, as you go into the black hole, in regions where it's highly curved, which means strong gravity, highly curved means strong gravity. Space-time curvature, space-time is gravity. So in a region of space that is highly curved, you get a phenomena, an enhanced phenomena of virtual particles flipping out of the vacuum and into reality for an instant, a very short time, and then falling back in, mating and pairing and going back out of the place. So it's a boiling foam or froth at that level of a lot of energy. If you were to, in nuclear physics class, they had virtual particles they were using to explain attractive forces. And if you have it in a collider and you hit the nucleus of an atom with that, because it's highly curved space-time, it emits and absorbs virtual particles too. You slam the thing away that does the curvature, all of a sudden these virtual particles that appeared but didn't have time to get back into wherever they came from, they now pop out of, they take some energy and become real. And so you get this cloud of virtual particles that became real particles, electron hole pairs and things.
Good grief.
Now, virtual particles, the key thing in virtual particles is they're not real particles in the sense, and it really plays with your mind, the virtual particles do not obey physical conservation laws, such as conservation of energy. So when they come into being, they don't have real energy and they pop out of existence right away. You didn't gain or lose any energy. You have to separate the pairs to get energy. They're trying different ways to try and harvest that or do it, and we'll see about that, but that's not this talk. But very curved space, like around a black hole, you end up with an uncertainty in the local energy density. Uncertainty causes weird effects near the event horizon. Hawking showed how quantum fluctuations allow energy to escape from a black hole, a process now known as Hawking radiation, and that's what we're going to describe coming up. He described this heuristically, a thought experiment, with virtual particles, antiparticle pairs, and with virtual particle-antiparticle pair. That is, you get one particle and one antiparticle pair that pop into existence, and an extremely short time later, they recombine it.
Now, virtual by virtual, what was the word? Virtual particle.
Yeah, virtual particles are opposed to real particles.
Right, and Tim,
they have no real existence.
Yeah, virtuous particles do obey quantum.
Okay, Mr. Pun. Dr. Pun.
Like Virgin Olive
Anyway,
oil.
but they are virtual particles, which means they do not obey conservation laws. So they can pop out, and even though it violates energy, they pop back in again before nature notices.
So you're saying that they kind of exist?
They are real, and you can, for example, you can catch them, and once you catch them, you become a source of energy. They can grab your energy, and then they can become real. Yes. And they pop out of existence and into existence very quickly in highly curved space. They do it more in large gravitational fields around the black hole horizon than they do around the Earth.
They'd be traveling really fast at that point?
They're not really traveling.
Okay.
So
it's happening all around you right now. You're just not noticing it.
Yeah. And the time that they are in existence technically are extremely short, trillionths of a trillionth of a second.
Okay.
There's an experiment that's been done where they take two charged plates, or maybe they're not even charged. The Casimir effect?
Yeah, they're not charged.
Okay, so they take these two metal plates and they put them really close to each other, but not touching. And you can have these vertical particles appear, but one can escape in that case too.
Yeah.
Out the edge, out the space between them. And it actually causes an attraction between the two plates, and you can measure it. So it is really going on, but you just don't notice it.
Yes.
This one's hard for me to visualize.
Okay, what you need to visualize is the vacuum of space is not nothing. The
Okay.
vacuum is a real thing. Nothing is real.
Okay.
Okay, as the virtual part, now here's a virtual pair of particles that popped in out of existence because space is very curved right there. But before they can separate, before they can recombine, not separate, before they can recombine and go back to where they were, one of them falls into they're right next to the event horizon. So one of them falls in. Ah! What happens to the other particle and its energy? It's lost its sibling and is now free to escape. It now becomes a real particle. This process happens many, many times, and bits of energy radiate from the event horizon. So it takes a little bit of energy away because it broke this pair.
Huh.
It takes a teeny bit of energy out of the black hole. That's what radiates. And so
they're just showing these particles with the plus and minus. It doesn't mean real and anti necessarily, because they're showing it as though all one kind escapes.
yes,
You actually get both.
yes.
Oh,
This
really?
process, okay,
Now, is this the Hawking radiation here?
yes,
Yeah.
this is Hawking radiation. This is
Okay,
where it comes
okay.
from.
But anti would really be bad news, wouldn't it? And that's when we get the annihilation.
Only if it runs into a non-anti.
Yeah. If this black hole weren't there, these two guys would pop into existence and then they would see each other, they'd recombine, and they'd go out of existence.
Hey, Jerry, all you had to tell me was that look at these cartoons, and I got it.
That's why,
Except, are you describing entanglement?
no.
But there is entanglement involved.
Uh-oh.
Okay. The full physical picture is a bit more complicated, but the net result is the same. A black hole loses energy and faintly glows because it tears these apart. And it's the source of that. It takes energy to tear them apart, and the black hole is the source, the energy it's stored.
Ah.
But somehow the black hole fizzles away over time by doing this, doesn't it?
It eventually will go away.
But how can it do that if it's getting a perfectly good particle for every one it loses?
Because it takes energy away, it gains a particle, but it loses energy.
Oh,
And
okay.
energy
So
is mass,
it's
remember.
a net loss.
Yeah.
So instead, they emit black body radiation. This is a Planck radiation curve. This is the wavelength. This is long wavelength, like down near infrared. It doesn't emit much of that. It's got a temperature. This is the peak emission intensity at that temperature. So you can calculate what the temperature of a black hole is, and that's what Stephen Hawking did. This is the same form of radiation that is emitted by other objects that create heat. So the sun is a surface of 5,800 degrees, and it has a curve like this. A campfire is 800 Kelvin, and it has a curve like this.
But shifted more to the right.
Yes, as you get cooler temperature, it goes down. All cooler temperature curves are under a higher temperature curve. So curves of different temperatures never cross. So here at CAT at 312 K, which is about, CAT is about 101 degrees Fahrenheit. They have a slightly higher temperature, body temperature than humans. We're at 98.6. Cats are at 101. So, except sometimes when mine sees a mouse, it's at 110.
Yeah.
Anyway, and this is at 312. It has another curve that peaks way out here. And then the black hole, Sagittarius A, is at 10 to the minus 14 Kelvin. That's a very cold temperature, but it is a non-zero temperature. They all have a temperature, including black holes. So black holes emit radiation. Could we detect the glow from a black hole? Maybe. The uncertainty in energy density at the event horizon and thus emission is related to the curvature of space-time.
Huh.
Never heard the term black body before.
This is what?
The black body
The word
radiation.
black body on there.
Yeah, that's another one like plasma for me, Ronnie. I never get it.
But that's how you tell the temperature of things that are in space, is you measure the radiation that comes off and you construct that curve and it tells you the temperature.
Okay. Okay.
But my understanding of the definition of black black is not a color. It's not on the spectrum. It's absence of color, isn't it?
That's right. Everything that hits the black body is absorbed. Nothing reflects off the black body. But the
So,
black body does glow a little bit. This one does.
so black body is a new word.
Yeah. It's the source. It's the god of infrared radiation. You compare everything to a black body. You construct instruments in the lab that mimic a black body.
It's the birth of quantum mechanics, because when thermodynamicists started looking at it, they figured out that, hey, you know, it results in these quanta coming out, that it was like particles of temperature.
Oh, wow.
Well, Tim, if you want to learn more about this, make sure you make it to the September 4th meeting, because our young man that Chuck turned me on to, Darius Yamani, is a particle physicist out at UCSB, and he's going to spend the whole hour talking about quantum. I told him to be gentle with us, but he's booked.
Okay, so as the black body loses, it radiates away, it loses energy, it shrinks. A black hole that's not getting fed will get smaller. Smaller black holes equal more highly curved. More uncertainty and that means more uncertainty, and that means more emission. So the smaller it gets, the hotter it gets, the more it emits. It gets smaller and brighter and more radiation. Eventually it will die in a burst of high energy radiation. Very small, you know, what happens if a black body the size of an atom gets into the earth? There are science fiction stories about that, about slowly chewing away and eating up the earth.
A black hole.
Yeah. That's a black hole, and that's not going to happen. This thing, teeny black holes, teeny tiny black holes are created in the Hadron Collider in Switzerland. And somehow a news guy got a hold of that, and he said, "Oh my God, they're going to eat the earth, and you got to stop this experiment." And so they, in the lab, they hurried up all their experiments because they knew it wouldn't happen. And they got the experiments done before there was any public backlash to stop the experiments. Because those little teeny microscopic black holes don't have a long life. They're so close to the end, they just pop out of existence. For primordial black holes, this evaporation will take about as long as the age of the universe. The Fermi Space Telescope is searching for the faint signs of black hole deaths. And now comes the conundrum.
So they've never seen a black hole death?
Many black holes have died.
Okay.
You have not seen it because you don't know where to look.
Oh, okay. Got it.
But they do happen in the collider. But if black holes die, we have a problem.
So in a quantum world, do they die and not die at the same time?
That's a very good question.
Only if you open the box.
Okay, you're giving me an Excedrin headache.
Yeah.
What happens to everything inside of them? That is information. Now, I know humans tend to think of information as an incidental thing, not a real physical thing. But actually, information is what you and I are, that is expressed in organic molecules to be alive. But we are fundamentally information. And that's a real thing. It is conserved. Information can be created, but information cannot be destroyed in the universe.
Oh boy. AI is going to have a field day.
No, I got this from AI.
Okay.
What happens to everything inside them? Let's revisit the particle lost to the singularity. Its sibling has not forgotten about it as they are entangled. Ta-da!
There's your entanglement.
The lost particle has information about the state of the particle pair. Hawking believed that black holes destroy this information, which violates a core principle of quantum mechanics. It contradicts its unitarity. The initial state of a system can be determined from its final state. This is impossible if information about an initial state is destroyed.
Oh.
This is known as the information paradox. All three things as we currently understand them cannot be true at once. General relativity, how black holes work, quantum mechanics. So what is the solution? This is very robust. Maybe black holes don't actually destroy information, but this is hard to show. Maybe unitarity is wrong. Maybe quantum theory must be revised. Anyway, that's the question that this leads up to. But if information cannot be destroyed, when your body is destroyed, your information is still in the universe. Why might a human safely away from any black hole care? It can help us understand why you're even around to wonder this. Our universe began in an extremely dense state in which quantum mechanics dominated. We can't replicate this on Earth, but black holes give us a present-day laboratory to explore similar conditions. Hawking radiation is a clear example of a clash between general relativity and quantum theory, but it is also a process that can be explained only through the application of both. The solution to the black hole information paradox could be the key to describe our universe under a unified framework.
Maybe.
Could be. Could is conditional.
But the general relativity is the gravity one, isn't it?
Yes.
Gravity and space-time and all that stuff.
Yeah.
I think the key, I was thinking about gravity the other day, Jerry, and I was thinking, okay, you know, it's what is the inverse of the distance, inverse masses and the distance between them. But I don't think anybody described what gravity is.
Yes, they do.
It's the curvature of space-time.
Yes, it's space folding into space folding into time, essentially. It's a rotation of space-time.
But Jerry, is this the source of some of those crazy videos I see on YouTube, even featuring Brian Cox, I think, talking about maybe we're all in a black hole?
That's another thing, and we could well be. That's a testable theory. In principle, they're working on trying to define the test that'll determine it. But they're relying on black holes rotate. And if we're in a black hole, we're probably in a rotating black hole. And if that's the case, then all of our galaxies inside with us will have a preferential rotation orientation. And it looks like about 75% of all the galaxies we see are rotating one way. It's not uniformly distributed. So we're trying to decide what that means. Could be a bright idea, could be fallacious.
I think it's going to come down to gravity.
Yeah, but anyway, that's it.
Maybe we'll get Dr. Brown to change the name to black body holes.
Black body holes.
This is a wonderful hour, Jerry. Thank you.
Okay, you're welcome.
I guess if you're going to get a PhD in astrophysics, you got to understand everything you just said.
No, there's a lot in there that nobody understands. You know, when I was taking quantum mechanics, from people like Richard Feynman, he said, if you ever meet anyone, including a physicist, who says, I understand quantum mechanics, that person doesn't.
Wow.
Well, I hope that Tim and I aren't lost in early September when we have the young man from the particle physics department.
We're working on
it. Okay, what color is it then? Is that an all new color? Is that what we're going to say? Black body?
It's to the red end of the spectrum, way down there.
Red holes.
So I don't think the word color means wavelength, and
black is absence of that. That's what I've always heard. Shall we do it again, gentlemen? Number 269 is a week away, and in 3 weeks we get to meet again in Fleischmann Auditorium for Dr. Freeman on Curiosity, which is climbing the Mons on Mars. Gentlemen, thank you. I think I learned a lot today. I'm going to go have nightmares about it.
Okay.
So how do we say goodbye, Chuck?